Okay, so let's start with our warm-up here. We're still going to be using Desmos today, but you actually won't need Desmos at all for this warm-up. Okay, everybody see my scatter plot over there? Okay, it says, Gianna wants to buy a specific make and model of a used car. She has researched prices from dealers and private sellers and made the graph shown. Question, how many cars has she priced out? 10? How do you know that? Nope. How can I figure out how many dealers she's talked to and how many prices she's gotten? Nope. The X is the age of the car. The Y is the price in dollars. I'm not asking you about either of those two. I want to know how many people she's talked to. Number of points on here. So how many points do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. She's talked to 11 people about the price of this car. And they all have data points there, okay? All right, part A says, what's the relationship? What do you think? Decreasing, which is called negative. Okay, now describe it. What's on the x-axis? Age. So as the car gets older, what happens to the price? The price goes down. Good. As the age increases, the price decreases. Folks, does that sentence make sense? Yeah. Older cars cost less, don't they? Okay. Next, it says use the line of fit. Folks, is there already a line of fit on this graph for you? Okay. Use it to predict the price of a car that is 7 years old. Where do I see 7 years old? Is that an X or a Y? 7 years old. That's an X, which would be right here, wouldn't it? There's already a line on there. So I can go up to that line and I can predict how much would that car cost, you think, approximately? 7 years old. How much does it cost? 3,500. So what would you call that? You wouldn't say 3.5. You would say 3,500. Yep, you got it. Everybody doing good? I knew what you meant, but you just wouldn't say you owe me $3,500. Yeah. All right. Finally, it says, is it reasonable to use this line of fit to predict the price of a 10-year-old car? Explain. So what do you think? Should I use this graph to predict the price of a 10-year-old car? Why or why not? Okay. Okay, so how much does it say a 10-year-old car costs on this graph? Nothing. Do you think that any car, no matter how old it is, would cost you nothing? It's at least worth something for A, the scraps, B, the parts, something, right? Something, maybe even if it's $100. The car is going to be worth something, agreed? So your answer here is going to be no, it is not reasonable. But I want you to write your own description, your own sentence. So tell me why. Okay, I just kind of gave you an example there. A car has got to be worth something. It can't be $0. If I went up to Logan and said, okay, how much for your car? He's not just going to say, here you go, you can have it, right? No matter how old it is. At least sentimental value. There you go. Yeah, that too. Yep. You got it. All right. Yeah. And low miles on it. Yeah. Some people even fix them up so they look like they're perfect condition even. Yeah. Yeah. Oh, yeah, because it only goes so fast, right? Yeah. All right. So, folks, what are we talking about today? Yeah. Isn't this the same thing we've been talking about for like 3 days now? So tell me, what is a line of best fit? Oh, you got it on notes from the past 2 days. Come on. Tell me, what's the line of best fit? What do you think, Braden? Okay, and what does that line show? The correlation, which we have in the slope, that's the same thing. That's called the trend. So a line of best fit is a trend line through the data. And folks, previously, how do you know where to draw your line? I give you 2 points, don't I? And I say, okay, connect them. Yes? Well, that's me choosing the 2 points, yes? Well, if you look at your notes there today, do you see those tables? Are there more than 2 points in those tables on your paper? Yeah, we're going to actually use all of the points today because we're going to use something called linear regression. And this is a computer program that calculates the best line. The best line. So it's not just Mrs. Cannon telling you what 2 points to use. You are actually going to put in every single point, and then Desmos is going to make the best line for you. And by best line, I mean it goes through the most points. It goes right through the middle. Does that make sense? Okay. You're going to have a really long table today. Yep. What form do you think it's going to be in when it's done? Yeah, it's not going to change. Folks, you've already been doing linear regression. I just haven't been calling it linear regression because we've only been using 2 points. Does that make sense? Okay, but we are going to talk about something today called the correlation coefficient. Don't you guys already know what correlation is? Correlation is either positive, negative, or none, yes? Okay, well now I have something called the correlation coefficient. And this tells me how strong the relationship is. How strong the relationship is. And we're going to do this by looking at a decimal. And I want this decimal, if it's going to be super strong, to be really close to 1. Okay, did everybody hear me loud and clear there? Okay, now it could also be really close to -1 because if I have a positive correlation, the correlation coefficient is going to be positive. What do you think is going to happen if I have a negative correlation? The correlation coefficient is also going to be negative. Does that make sense to everybody? Yes? Okay, so for example, I'm going to relay it back to tests for you. Okay, would you like to have a 95% on a test? Oh, yeah, you would. That's a really good grade, isn't it? That means that would be a strong relationship on our graph. Make sense? What about like a 65? Probably don't really want a 65, right? So that would be a not so strong relationship on our graph. And I'll show you what that means as we go through. Fair enough? Ready to go? All right, so take a look. I've got a situation for you. I'm going to read it. You follow along. The table shows the amount of money made by movies in the United States. Use a graphing calculator, aka Desmos, to write an equation for the best fit line for the data. Now, does everybody see how this is talking about years? Am I going to put in 2000 for my first year? No, whatever your first year is, that is going to be 0, and then we go up from there. So I would like you, please, to note what your new x's are going to be on your table. Now, once you have that, you're ready to enter all of your data into Desmos. So go ahead. In your table there, which you already should have, we're going to type in all of these numbers. Everybody okay with that? Can you start typing them in for me? Okay, if it were me and I'm doing this, I would tell you to go through this and type all your x's in first. That makes sense, everybody? And then go through and now type in all your y's. And folks, I'll tell you, this is the part that takes the most amount of time. After you get all this on here, the rest of it is pretty easy peasy. And I would suggest you to move your graph so you can see your data points. And it should look something like that. So here's what I need is for when you get this up there and you get all your points up there, look and see if it looks like mine. If not, there's something wrong and you got to go back and look at your points. How we doing? Do your points look like my points? Does it make that little hump in the middle? And then it kind of flattens out? Dalton, how you doing? Okay? Brayden, you doing okay back there? Luke? Logan? Quentin? And now we're ready to answer every question that I want to know about this. Are you ready? We ready to answer the questions or no? Now yours looks a little different than mine because I tried to save some room here. So my first question says equation of the line of best fit. That's your first question, right? Look at your M and your B. You see them down here? Okay, I'm ready to write an equation. Can somebody read it off to me? And hold on, actually, 1 second. Tyler, I only want 2 decimal places, okay? So whatever the third decimal is, that's what you're going to use around. Okay, so y equals isn't it an 8 and then there's something after it? So I want 0, 9 then. Does that make sense? Guys, how everybody doing with that equation? Fine? Okay, now it says describe the relationship. So look at your scatter plot. Positive, negative, or none? Go up, down, or all over the place? Positive. And I'm pretty sure that this line is over here on yours, isn't it? Okay, so you're going to write it over there. Positive. What does that mean in this situation? What are my x's? Years. So as the years go by, what happens? The income does what? Goes up or down? Increases. So as years go by, the income increases. Again, I tried to save some paper by putting that over there. We got that written down? Okay, now it says if the correlation coefficient is, guess what? Desmos calculates that for you too. It's amazing. Does everybody see the R above the M and the B? Does everybody see this R right here? That's your correlation coefficient. So you're going to write that in that blank. Just the R. What's it say there for R? 0.8755? Did I remember that right? Okay, so what percentage would that be equivalent to on a test? 87%. What would you think about an 87 on a test? Pretty good, right? So what would we say? Would we say this relationship is really strong, or not really strong? Strong. This is a strong relationship. Now, folks, what that means is if I'm going to make a prediction, that prediction is going to be pretty accurate. Okay, so this next part here says predict the income in 2012. Am I going to type in 2012? No, what was my starting year again? 2000. So how many years have gone by if I'm at 2012? So you're going to plug in a 12 into your equation for the line of best fit. Now this is a year, isn't it? Are the X's or Y's years? X's. So this is going in for the X. So 0.23 times that 12 plus 8.09. Grab your calculator, type it in, make a prediction. What will the income be in the year 2012? 10.35, you said? 85, excuse me. So $10.85? No, what does this mean? Billion. You guys all see the billion in parentheses over there? So this is 10.85 billion. Definitely a big difference, right? Between $10.85. What do you guys think? Can you handle this? The only thing that's different is now you're entering in more points, aren't you? That's it. We ready for the next one? I forget what's the situation on the next one. Years? Goals? Oh, hockey. This is right up your alley, Brayden. Right? All right, so take a look. I'm going to read the situation to you. It says, write an equation of the best fit line for the data in each table. Name the correlation coefficient, round to the nearest 10,000. Let x be the number of years since 2003. All right, so we're talking a girls' hockey team here, right, folks? What year does this whole party start in? So that is my 0. And then we have 1, 2, 3, 4, 5, 6, and 7. And then on the bottom, that's their number of goals. Does everybody see that? Okay, so you've already got your table. Delete what you have there. Actually, you probably don't need to delete the whole thing. We still have the 0 through 7, don't we? Yes? So what I would do is delete. I don't need those two, do I? Because I'm only going up to 7 this time. Does that make sense to everybody? And then I'm just going to change my y's. So the first one is 30, 23, 41, 35, 31, 43, 33, and 45. It looks like I'm going to have to zoom out a little bit here. How we doing? We doing okay? Now let me ask you this. This line compared to my last line, are the points farther away from the line or are they closer to the line? They're farther away, right? Which means this line isn't as good as the last line, which means the correlation coefficient should not be as good. What is the correlation coefficient here? You guys see the 6142? Yes, write that down in the blank for correlation coefficient. 6142. 0.6142. Yep, you're on the back. Everybody have it written? Yes? Okay, let's go back and answer all the rest of these questions. All right, can you give me the line of regression? Y equals what? Remember, I want 2 decimal places. What's your M? 1.87x? Yep, and then plus what? 28.6. What's after the 6? Oh, so it should be... Oh, so you're right, 28.6. Good, Dom. Yep. All right, what would you tell me? Positive, negative, or none? Positive. Can you write me the situation here? What would it mean to be positive in this situation? What are my x's? As years go by, the goals increase. It is. The only thing is different is we're adding more than 2 points. All right, now tell me what that correlation coefficient was again. Does this look like your paper here, folks? How we doing? Yeah, some of you keep... Oh, I'm sorry, it got cut off, didn't it? Like the chart is on the front and I'm sorry about that. Whoops. We're okay? Okay, so what percentage would this be on a test? You think you want a 61% on your test? Probably not. So really strong, strong, or not really strong? Not really strong. Not a strong relationship. So that means that the points are a little bit a ways from the line. And if you look at your graph there, those points are a little bit far away from that line, aren't they? Okay, now I'm going to make a prediction, but should I really count on this prediction? No, because the relationship was not strong, was it? Trick question, though. This says I'm going to do this for 2014, yes? What year did I start in? 2003, didn't I? So if I started in 2003, how many years have gone by for me to plug in? 11. You are going to be plugging in an 11 because that's how many years have gone by. So tell me then, what would you be typing into your calculator? Did you guys see how she just took out the X and put in that 11? Yes, no, maybe? Yes. All right, so how many goals are we scoring in 2014? Now, can I score 0.17 of a goal? 49 goals. 49 goals. You all think you can recreate this on your own? Yeah, you do? Okay, so let's just do one more then. This is talking about 10 tallest buildings. Folks, am I talking about years in the X's? No, so do I need to change these numbers? No, you can type them in exactly how you see them. So go ahead, type in your data. You don't need to change them at all because these aren't years. So we type them in exactly like we see them. All right. How's your data looking? You guys getting fast at typing those numbers in? Yeah. You will be using Desmos on your test on Wednesday. You will be using it. How do your points look? Pretty similar to mine? Got a little cluster down there at the bottom and got a kind of point off by itself. Wait. Everybody doing okay? All right, I think I'm ready to answer my questions then. First thing I want to know is what is my line of best fit? Say it again. Y equals what? Say it again. 10253, like that. How we doing, guys? Doing okay? And I believe I only have this question for you, don't I? I didn't even ask you for the rest of them. Okay, so we're going to do one more because I literally only asked you one question about that. Do you want to do the next one or the very bottom one? What do you think? I think you're outnumbered there, Mr. Stahl. We're going to do the very bottom one. Can I ask you something about this one, though? What would this first box be for the X? No. Do you see how it says since 2004? 0, 1, 2, 3, 4, 5, 6. Can you guys just write those in there? We're not going to do this problem, but just write them in there so you know that whatever that first box is, especially since it says since 2004, that first one is a 0. All right, so we have this last guy here, huh? Okay, well, we got years again, don't we? Since what year? What year did this whole party start in? 1975. So this first box is going to be what? 0. What's the second box going to be? No. We started in 1975, didn't we? So this is going to be 5. Do you see how that's 5 years later? You got it. 5, 10, 15, 20, 25, 30, 35. Do you see how you actually have to look and pay attention to what's in front of you? Yes? Okay, let's get all that data in there. Yeah, I'm going to clear this whole table because they're all different now, aren't they? Yeah. Okay, so we start at 0. I'm going to do all my X's first, I think. 0, 5, 10, 15, 20. How far do I go? 25 to 35. Thank you. All right. Okay, can I get somebody to read me off my Y's? What's the Y for 0? 0.95 or 2395? Okay, next. There's no decimals in these, right? Okay. 10. Okay. 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 17,813. Oh, that's a big one. Okay. Like that. Oh, 2673.5. I missed that. 2673.5. Okay, now, yikes, where are my points at? Right there. Now, folks, I don't think I'm going to be able to see my points on here. Do you see how far away from each other they are? Okay, so I think that's probably the best I'm going to get. Does everybody see my M and my B? Do you see your correlation coefficient? Can you fill all that in for me? Yes, no? All right, so tell me, what is the line of regression, the line of best fit? Pretty big numbers, I think, right? What we got? Y equals? Look at your M. Yes, 600 and something. It should be, right? Say it again, Quentin. And that's X plus. What's your B? I can't. These earphones, I can't hear you, kiddo. Like this? Okay. How'd you guys do? Are those the same M and B that you have? Oh, those aren't the same M and B that I have. I have 671.95. Ladies and gentlemen, do you have 669 or do you have something different that Quentin has? You have 671. Where'd you mess up so I can tell Dalton where he messed up? The 30 column. You don't have the right number in the 30 column. You have the same as me? How about you, Tyler? You have the same as me or same as Quentin? Okay. So you should have this, folks. This is the correct answer. 671. Brayden, you got 671? Okay. So let's fix it back here then. Whoops. Can you read that off to me now? 671, what's the decimal? So 0.94. So 0.96. And there's an X on there, right? What's my B? So 0.17, you said, right? How we doing, guys? What's the relationship? Positive, negative, or none? Positive. Isn't my slope positive, folks? If the slope is positive, then it's positive. So we're talking about years. So as the years go by, entrance, right? Is that what we're talking about? Entrance increase. Oh, we're talking about the Boston Marathon. So every year more people run it. You guys ever seen that on TV? It's pretty cool. You guys ever heard of the Boston Marathon bombing? Yeah. 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 Uh-huh. Crazy. Yeah, I bet. Oh, for sure. I bet. Okay, you got your correlation coefficient there, the R? What's the R? Point what? Like that? So what percentage would that be? You want a 96 on a test? For sure, right? So how strong is this? Very strong. This is a very strong relationship. Okay. What year? So my prediction is going to be pretty spot on, isn't it? That I'm going to do next. What year do I want to predict in? What year did I start in? So I'm going to subtract these to figure out how many years went by. How many years have gone by from 1975 to 2003? How many? 28, she says. So that is what I'm plugging in to my equation. So I have 671.96 times that 28 plus a 395.17. How many people would you expect to be running in 2003? Remember, I can't have a decimal of a person. Like that. Okay, I got one follow-up question for you. How many runners were in the very first Boston Marathon? Nope. Don't Google it. From this up here, Tyler. Look at your equation. Does everybody see the equation we wrote? Where does this equation begin? Where does it begin? Right there. Isn't that my beginning number, the number on the end? Haven't we talked about this? That's where the graph starts, correct? So from what I have here, it says there'd be 395 people that ran the first Boston Marathon. I don't know if that's right or not, but that's what this equation tells me. And the very first Boston Marathon, that might be the most recent Boston Marathon. There was no way 30,000 people in 1897 ran the Boston Marathon. In 1890, there was only one Boston Marathon. All right, so you guys are going to have a worksheet, so I'm going to pass that out to you now.